Hi everyone, and welcome to today's tutorial session. Today we want to find all the possible values of the variables a and b such that a squared minus b squared is equal to 49. So please, we intend to bring a clearest possible solution. So we are advised to watch the solution from the beginning to the end. All right, let's start. A squared minus b squared is equal to 49. If you look at the left hand side, it is actually a difference of two squares. So we'll bring in the difference of squares identity here. When we apply the difference of squares identity, we obtain a minus b into a plus b is equal to 49. All right, we have this product giving us 49. It means that there's a possibility to have products of 49 that will match what we have on the left hand side. So the first thing to do now, or the normal thing to do now, is to decompose 49. All right, 49 can be decomposed as 49 times 1, or 1 times 49, or 7 times 7. Those are the possible factors of 49. So the left hand side is a product of two expressions. So we want to also convert this as a product of two expressions and work out to see the possible values of a and b. Now, therefore, let us take the first case. If we take the first case, 49 multiplied to 1 to be equivalent to this. Therefore, we are saying a minus b into a plus b can be expressed as 49 times 1. All right? This product giving us this product. So if we match them, position for position, this first position go with this first position, this second position go with this second position, then we are saying that a minus b is 49 and a plus b is 1. Remember, a and b are natural numbers, positive whole numbers. Now, let's look at this. The difference between two natural numbers, 49, the sum of two natural numbers, 1. This is really absurd. It's really absurd because how can the difference be bigger than the sum? So we see that therefore this assumption will be thrown away. To assume that the left hand side is 49 times 1 is a wrong assumption. So let's take now the second assumption, that the right hand side is instead 1 multiplied to 49. All right, if we do that, therefore we are coming here, we're now saying a minus b into a plus b is 1 multiplied to 49. All right, matching things up like we did earlier. So we are saying we have the system a minus b is equal to 1, a plus b is equal to 49. All right, this is possible. The difference of two natural numbers smaller than their sum. All right, this makes sense. This system makes sense than this one. All right, let's go ahead and solve that system. Let's call the first equation, we'll call it equation 1. Call the second equation 2. So we have these two linear equations to solve simultaneously. The coefficient of b here is -1, the coefficient of b here is +1. So we can eliminate b by simply adding the two equations. So we say 1 plus 2. Remember, this means equation 1, this means equation 2. So we're adding the two equations. So when we do that, we'll have 2a. This will obviously give us 0 is equal to 1 plus 49, 50. So we have 2a equals to 50. From here, if we divide both sides by 2, we obtain the value of a as 25. The value of A is 25. Now, taking this value of A, we can substitute in any of the two equations, equation 1 and equation 2, to get the corresponding value of B. So if we take, for example, in equation 1, okay, if we take equation 1, then we're going to obtain 25 minus B is equal to 1. All right, remember we're looking for B. This is negative B, so we take it that way, become positive B. We take 1 from the right hand side to the left hand side, it becomes negative 1. So we have 25 minus 1 is B. This means that the value of B is 24. All right, so our first pair of values, AB, will be 25, 24. All right, that gives us our first pair of solutions. So we now have to come down here and test the other proposal here to see if it is workable. And if it is workable, then we'll also solve for A and B. Remember, we want to get all possible values of A and B, for which this difference is actually 49. Okay, so that's done. Let's continue this way. Okay, so now we want to consider this system 7 multiplied to 7 to replace 49. Okay, so we're saying uh, A we're saying A minus B into A plus B is actually equal to 7 times 7. All right, here we have replaced 49 with 7 times 7. Okay, we have replaced 49 with 7 times 7. So let us now bring out our two equations that we did earlier. It means A minus B is 7, which we can call equation 3, since we already have equation 1 and equation 2 there. Then we also have A plus B is equal to 7. We call that equation 4. Okay, now this is possible because the difference of two natural numbers can give us the same result as their sum. For example, the two natural numbers are 0. Okay, you see, we obtain the same result. If the two natural numbers are 0, we obtain the same result. If one of them is 0, and so on. So let's go ahead and solve. Again, we add the two equations, equation 3 plus equation 4. If we do that, we're going to obtain 2A is equal to 14. Okay, so if we divide now both sides by 2, we'll obtain the value of A to be 7. Now, if the value of A is 7, it automatically means putting A equals 7 in, let's take equation 4, for example. All right, this is our equation 4. So we're saying 7 plus B will give us 7. Okay, so what is B? B will just be 7 minus 7. So the value of B will be 0. All right, so next pair of solutions, this is the first pair. Next pair of solutions will be 7, 0. Okay, 7, 0. All right, so we've got two pair of solutions, 7, 0, 25, 24, for the values of A and B. All right, so can we test and see if our solutions are correct? Checking. So we are checking in this expression. So let's take the left hand side. Let's work with the first one, 7, 0. 7, 0, left hand side. A is 7, B is 0. So let us see if we obtain the right hand side. This is 7 squared minus 0 squared. This gives us 7 squared, which is 49. And 49 is equal to what we have on the right hand side. So the solution 7, 0 is verified. Now, what about the other solution? The solution 25, 24. Let's take the solution 25, 24. 25, 24. Let's take the left hand side, okay, to see if we'll obtain the right hand side. A is 25, so we'll have 25 square. B is 24, 24 square. What do we obtain? Do we obtain the value of the right hand side? 25 square, 25 square, we found it to be 625. 24 squares is 576. Now, if we do that subtraction, we're going to obtain 49, which is our right hand side. Therefore, the solution 25, 24 is also correct. Remember, it's not advisable to try to swap because here we have a negative there. And so we have to be very careful. Okay,